Hi, this is Surely Physics, cross products and the right-hand rule. It's just an introduction to using IJK notation, what the definition of a cross product is, and also figuring out the direction of the resulting cross product of two vectors. The first thing I want to talk about is the IJK notation. Um, so I hat is referring to the direction of the x-axis. J hat is referring to the direction of the y-axis. And in three-dimensional space, there's also a z direction. It's coming sort of out of the page here, and that is the k direction. And this is pronounced in language use k hat, I hat, and j hat. These are called unit vectors. And unit vectors have a magnitude of 1. So I has a magnitude of 1, so if you multiply anything by I, that number is still itself. It just now has a direction in the x direction. And that's what it would mean. So like, for example, if vector A, and this is a vector notation, this denotes that this quantity A has a direction to it, it's a vector. If vector A is 10I, that means it has a magnitude of 10 in the x direction. If we add onto it a negative 2j, that means it also has a component in the negative y direction with a magnitude of 2. And finally, if we add on a k, that k hat, that means it has a magnitude of 1 in the z direction. So if I try to plot this out, it'd be rather long in the x direction with a 10. So like 10 over, 2 down, and 1 in the positive z direction. So I'd have to move it out here. So the resulting vector A could be drawn spatially like that. Okay, so 10 over, 2 down, and 1 out. That would be the dimensions and the direction of that vector. All right. So if we have a second vector, B, and I'll give it a negative I plus 5k, we now have two vectors, and they each have their own unit vectors. Vector B is in the direction of the negative x and positive z axis. So it's in that xz plane. It's sort of like along the sheet. It'd actually be a little bit to the side over here. Let's see, vector B, if I plotted this out, it'd be a little bit out this way. I'm just sketching it, and out in this direction 5. So that might be representative of vector B. It's in that plane. Now A is not in the XZ plane. It's not in either of those regular quadrant planes. It is down from the XZ plane. So because it has that Y or that J hat component there. Okay. So if we were to multiply those two using the vector product, also called the cross product, A cross B, when you take the cross product, only the perpendicular components are multiplied together. So what that means is, if we're to take a 10I minus 2j plus k and cross it with negative I plus 5k, you'd handle it just like normal algebra. We'd have to distribute each one of these. So I'd have to take a 10I cross negative I plus negative 2j cross negative I plus k cross negative I. So I applied all those to the negative I, Now I'm going to apply all those, multiply them by the 5k. So we're also going to add on here a 10i cross 5k minus or plus a negative 2j cross 5k plus k. Here's our last one, cross 5k. All right, there it is. All right, what do we do now? What about all these crosses? Well, if we take 10 times negative 1, that's of course negative 10. However, the cross product is the product of perpendicular vectors. So by definition, I hat cross I hat is 0. It has no magnitude at all because it's in the same direction. Those two unit vectors are in the same direction. However, I cross j is 1, has a magnitude of 1, but it also has a direction of k. Now, using unit vectors, there's a little trick to this. What if I have j cross I? Well, that would actually be a negative k. We'd have it going in the opposite direction. So I'm going to explain this to you a couple ways. One is with the right-hand rule. Okay, so I'm going to zoom out here a bit and show you with my right hand. The right-hand rule says you take the first vector, in this case it would be an I, we're going to cross it with j. If this is my x direction, and that would make this direction the y. So if you can kind of turn your face a little bit, okay? Here's the x and the y. Which way would be the z? The z would be coming out of the page. So that describes the right-hand rule exactly. If we cross I with j, then my thumb going up towards you is going to be in the z direction, or the k hat direction. Okay, so the right-hand rule, you can face your palm towards the direction of the second vector and point your fingers towards the direction of the first vector. All right, and so when you cross it, you can see that there's a parallel action or a perpendicular direction between the way your fingers are pointing and your palm, the direction of your palm, which is that way. And the thumb is pointing in the z direction. So what if I crossed j cross I, go backwards? What if I went backwards with that? J cross I. That would also have a magnitude of 1, but it would be in the negative k direction. You see, if I take my right hand, and this is still the x direction, but I want to now point it in the direction of j. So I want to go j is that way. But in order to have my palm facing the x direction, I'd have to turn it around like this. I'm twisting here. That way, I have j cross I, and my thumb is now pointing down into the page, away from the camera. So that's in the negative k direction. That's kind of how it works, and we'll get back to using that as we move ahead here. So zoom back in. There we go. All right, so how do you handle all this? I's, well, I cross I's are going to be 0. That's going to be nice. J cross J's, or I don't have any of those, but I have a K cross K. It's also going to be 0. All those crossing two unit vectors that are all the same equal 0. So how do I go to a j cross negative I? Whoa, what's up with that? Or I should just say j cross I. Or what about a k cross I? Well, there's a little trick I like to use here. Just write out I, j, k, I, j, k. Just put them like that. And draw a little arrow underneath with heads at both directions, with the positive on the right and the negative on the left. All right. So here's what you do. To go from, if you've got I cross j, you have to go I cross j is k, and that's all in the positive direction. Whereas j cross I, there's nothing over here, that's why we're going to skip over this part. J cross I is k, but in the negative direction. I had to go to the left. Left is negative, right is positive. So what would k cross I be? K cross I would be j in the positive direction, so positive j. How about how about k cross j? K cross j would be I with a negative I. So with that tool, it makes this a little bit easier. If we're to continue this problem here, what is A cross B? We would take, and first basically, the way I conceptually look at this is I'm going to multiply the coefficients first. So 10 times a negative 1 is a negative 10. Then I'm going to take the unit vector cross product. So I cross I. Remember, I already used the negative. I don't want to throw in a negative twice into this mess over here. So I cross I is 0. So that'd be a 10 times 0 plus. Now I've got a negative 2 times negative 1 is a positive 2. And j cross I, let's see, j cross I is k, but in the negative direction. So I'm going to put a negative k there. On to the next term, we've got a k cross negative I. So that's a negative 1 is the coefficients. And k cross I is positive j. There we go. Here I've got a 10 cross 5, so that's a 50. And then I cross k is negative j. Plus, so here I've got a negative 2 times 5 is a negative 10. And j cross k is positive I. And finally I've got a k cross k, so that even though 1 times 5 is 5, that'll be a 0 there in the end. So now if I simplify this a little bit, combine like terms, I've got an I component, j components, and k. So I'm going to start with my I just to keep it in the right order. Negative 10i. And then negative j plus 50 times negative j is a negative 51j. And I've got a leftover negative 2k. So my cross product of A cross B is this goober here. Now technically those negatives are not attached to the coefficients, they're attached to the direction. So let's get technical here. This is 10 in the negative, let's rewrite that. That's 10 in the negative I direction. And this is plus 51 in the negative j direction, and plus 2 in the negative k direction. Okay, so that is the cross product of that very ugly looking vector. So what if we've got actual like drawn or graphically written vectors? Drawing this one, this resultant on here, is going to go way off my scope here. So let's try a new one here. Let's try graphically. And we'll just stick with 2 dimensions here on this one. Got my x-axis and the y. So let's say I've got a vector A and a vector B. Okay, each of these has some components to it. They've got lengths. So let's say A is a length of 5, a magnitude of 5, and B is a magnitude of 2. Now I really haven't given anything else about this. We don't know how far this is stretching out or the angles, but there is, as you'll notice, a little angle between them. We'll call it theta. So one more definition of A cross B, and I think this is the more useful one, is that if you want the magnitude of that, and that's often what we're looking for, the direction can be found out in just a moment. Definition of those is if you take the magnitude of A times the magnitude of vector B times the sine of the angle between them. And that's a definition of those two. So if we do have the angle between these two vectors, we can determine that. Let's say if this is 20 degrees here and up to vector B, let's say that's 60. All right. Then theta would be 60 minus 20. All right, so that would be 40 degrees. So I could find the vector product or the cross product by taking 5 as the magnitude of A times 2 the magnitude of B, sine of 40 degrees. Okay, and you get a magnitude out of that. But what about the direction? A cross B would be 10 sine 40, but the direction would be what? What do you think? Well, if we take, let's try the right-hand rule here, A facing my palm towards B, the direction of B, so that's the direction that I have to rotate towards B, then the direction is up in the K direction, the positive K. Okay, so out of a couple of vectors in the XY plane, we get a vector pointing in the Z direction. So I could write A cross B, be whatever that is, 10 sine 40, in the positive K direction. Now, if you have a calculator, go and plug that in and figure it out. But that sums it up just as an introduction to vector products and IJK notation. I hope that was really helpful.